Yes, friend. Now, in this video again, torque is continued here. I told you in the last video, tau is equal to Rf sin phi minus theta. There I gave you the explanation that R sin phi is equal to B, so B into F. I also told that if phi minus theta becomes 0, here if phi minus theta becomes 0, then force will act on radius and sin 0 is 0, so torque is 0. So radial component does not produce torque if force acts along the position vector. Or other way you say if line of action of force passes through point of rotation, then force does not produce torque. It is the tangential component of force which produces torque. I told such things. But now one thing very important here. Phi minus theta is the angle between direction vector R and F. Since phi minus theta is the angle between vector R and vector F, therefore this equation can also be written as vector tau is equal to R cross F. While teaching vector product, I emphasize too much, but it is the nature of students, they keep on thinking other way. If this is something new, that's why teacher is stressing us to learn, but it is important here. I think you remember cross product, vector product. I am repeating again here. If vector A and B are there, then cross product comes normal to plane containing A and B. A cross B is equal to modulus A modulus B sin theta n cap. N cap is the unit vector which tells the direction of A cross B. A cross B is one vector which is at right angle to n cap unit vector which tells direction, and its direction is normal to the plane containing vector A and B. In this figure, A and B are lying in the plane of board according to right-handed screw rule. If you rotate screw A to B, it come out. If you put here a nut bolt system, so that screw come out. So direction torque is at right angle to the right angle plane containing vector R and F. And very clearly I told you here that body is free to rotate or forced to rotate in XY plane. Our force, this is radius, this is force, body rotating in XY plane. It means vector F and vector R here are in the plane of board. Vector R and vector F are lying in the plane of board. Therefore, vector torque will be at right angle to the plane of board, and here plane of board is represented by XY plane. So normal to XY plane is which axis? Z axis. Now if it is R cross F, anti-clockwise, so screw come out. So therefore this vector torque according to definition of torque, definition of cross product, direction of vector torque is normal to the plane containing vector R and F, plane containing vector R and F, and further determined according to the definition of cross product, direction of torque is normal to plane convector R and further determined by right-handed screw rule. In figure, vector R and F are in XY plane. XY, देखो figure in XY plane means it is the plane of board. Plane of board में है XY plane यहाँ, and therefore according to right-handed screw rule, vector torque is along क्या भाई positive Z direction. Z axis here is called axial rotation. In fact, for a long time I am stressing this point of rotation. Z axis, just like now your wheel rotates, cycle wheel rotates about axial. An imaginary line along the axial is their axial rotation. If speed is increasing, angular speed increasing, there is a torque, and that torque will be normal to plane of wheel and into it. If rotated anti-clockwise, the torque with increasing speed, then torque along positive, normal to plane and outward. You will understand so many things here, which are for you, and you people don't understand at all. Why this is happening? हाँ भाई, बहुत बातें हैं यहाँ पर, इसलिए मैं जोर लगा रहा हूँ कि आप समझें. वैसे तो बुक्स में जो है ना 1 सेकंड में समझा दिया, तो इक्वल टू R इंटू F. हाँ भाई, देखिए आप दो actually torque is produced by pair of two equal opposite forces. One force we have applied here, other force because it is fixed here. Like I told, the door is hinged. So hinge applied force, and we apply one other force on handle to close or open the door. Okay. Now torque here I have proved R cross F. Okay. So this torque here, अभी जो हमने कहा torque in this figure R cross F. So this direction of torque is along Z direction. we can write tau z also equal to Rf sin phi minus theta. We derive this thing from tau equal to xfy minus yfx. All these derivations are obtained from this equation. Which equation? Tau equal to xfy minus yfx. And direction of torque has come out along z direction. So we can write here tau z equal to xfy minus yfx. Similarly, tau y using symmetry, perpendicular symmetry, yfz minus zfy. जो यहाँ है एक्स वाई वाई एक्स उल्टा, क्योंकि वाई के बाद एक्स नहीं आता है, उल्टा होता है, वो यहाँ फॉलो होती है, एक्स के बाद वाई, वाई के बाद जेड, फिर यहाँ जेड है। और टो एक्स निकल टो एक्स इक्वल टू वाई एफ जेड माइनस जेड एफ वाई. And tau y will be zfx minus xfz. So tau x, tau y, tau z are three components of vector torque. Here, if tau is a vector, so in general, tau vector, tau can be written as this is very wide term, dear student, please think sincerely. Vector tau equal to tau x I cap plus tau y j cap plus tau z k cap. Tau x equal to yfz minus zfx I cap. Tau y zfx minus xfz j cap plus xfy minus yfx k cap. And if you remember, we can write this as tau equal to I j k x y z fx fy fz. And this is equal to also x I cap plus y j cap plus z k cap cross fx I cap plus fy j cap plus fz k cap. This is position vector R. And therefore vector tau R cross F. What is R? Position vector of the point P where force act on the body. Most general definition which cover all definition of torque is tau equal to R cross F. पहले भी किया था हमने आर एफ साइन थीटा भी याद था, बट नाउ इट इज थ्री डायमेंशन, दैट वाज ओनली अलोंग जेड एक्सिस. दिस इज थ्री डायमेंशन वेक्टर. टॉर्क वेविंग दिस. आई एम टेलिंग अगेन कि टॉर्क इज एक्सियल वेक्टर. Torque is axial vector and axis will be normal to the plane in which body rotates. Like here body rotates in xy plane anti-clockwise, then torque will along z axis. Positive z axis. If it will rotate clockwise, it will be along negative z direction. But remember, torque is axial vector. Now, we will solve many problems using this. Now, but important, actually it took 3 videos. Torque here in 3 videos. The unit I told you Newton meter, which is also called a joule. So in general, torque produced by a force here sometimes it will also call it as moment of force. Torque is also called moment of force or moment of couple means pair. If two equal and opposite forces act on a body, suppose this is any body and free to rotate about this point, and one force acting this way, other this way. Both have same magnitude. F1, F2 have same magnitude of direction. Vector F1 modulus F2. But their direction are in F1 equal to minus F. Okay. So they have same magnitude. So they rotate this body. And suppose, by the way, this point lies on the line joining them, note as that point should lie on this. For simplicity here, so magnitude of torque will be R into L. What is R? This distance. Perpendicular distance between line and two forces. Perpendicular distance. I will tell you one example in which it is known as that point of rotation should lie on the line joining the two. Product of magnitude of one force. Here F equal to magnitude of F1 equal to magnitude of F2. So, but most general definition is rho equal to R cross F. इसे याद रखें आप. In coming videos, I will be telling you concept of angular momentum. In Newton law of motion, force produce linear acceleration and change momentum. That was T equal to mv equal to change momentum per unit time equal to force. Similarly, there is one more term here, angular momentum. I will discuss in coming videos. Thank you.